200 pairs an hour. That's how many sneakers can roll off a single production line in a modern factory. One fresh pair hitting the conveyor belt every 18 seconds. But here's the thing, each one of those shoes is a masterpiece of precision engineering, robotics, and material science that would blow your mind if you saw it up close. Today, we're stepping inside the factories where Nike, Adidas, and New Balance turn raw materials into the kicks on your feet right now. Forget everything you think you know about how sneakers are made. We're not talking about rows of workers hand-stitching shoes anymore. Modern sneaker factories are part sci-fi laboratory, part high-tech assembly line, where giant robotic looms knit entire shoe uppers in minutes. Machines inject molten foam at 800 kilograms of pressure per square centimeter, and robotic arms apply adhesive with surgical precision. This is manufacturing at its absolute cutting edge. Let's start where every sneaker begins, with a single thread. The upper, where giant looms knit your shoe in one piece. Picture a machine the size of a small car, loaded with spools of colorful yarn, humming as it weaves your next pair of running shoes into existence. This isn't your grandmother's knitting machine. This is a CNC, computer numerical control, knitting machine, and it's creating what Nike calls fly knit, and Adidas calls prime knit. Here's where it gets wild. Traditional shoe uppers require cutting dozens of separate fabric pieces, then stitching them together one by one. A typical sneaker might have 32 different components that need to be assembled in a precise sequence, but fly knit technology throws that entire process out the window. Instead, a computerized flat knitting machine creates the entire upper as a single, seamless piece of fabric. The machine is loaded with polyester, nylon, or spandex fibers, sometimes up to 10 different colors at once. The newest knitting machines can handle multiple fiber types simultaneously, mixing materials with different properties into the same upper. Want a stretchy mesh section for breathability over your toes? Done! Need reinforced support around the heel? The machine knits it denser. It's all controlled by computer software that tells each individual needle exactly when to knit, tuck, or skip. But here's the million-dollar question. How does a flat knitting machine create a three-dimensional shoe upper? The secret is in the shaping. Modern flat knitting machines can create what's called fully fashioned construction. They knit the shape directly into the fabric by adding or dropping stitches as they go. The upper comes off the machine already curved and contoured to fit the human foot with closed edges all around. No cutting required, no waste. The machine even weaves in support cables and reinforcement strips as it knits. These aren't added later, they're integrated directly into the fabric in real time. Watch one of these machines in action and you'll see the fabric literally growing before your eyes, layer by layer, row by row. The knitting head moves back and forth at speeds up to 1.6 meters per second, and depending on the complexity of the pattern, a single upper can be completed in anywhere from 30 minutes to a couple of hours. Once it's finished, the upper gets pulled off the machine, and unlike traditional cut-and-sew construction, there are almost no scraps left behind. The environmental impact? A fly knit upper reduces waste by about 60% compared to traditional methods. One machine, one piece, minimal waste. That's the future of shoe manufacturing. The sole injecting clouds of foam at 1,200 bar pressure. Now let's head to the other end of the factory where the magic of cushioning happens. If you've ever wondered why modern running shoes feel like walking on clouds, you're about to find out. It all starts with tiny white pellets of EVA, ethylene vinyl acetate, a foam material that's become the gold standard for sneaker midsoles. The process is called injection molding, and it's equal parts chemistry and precision engineering. Here's how it works. Those EVA pellets get loaded into a hopper and fed into a heated injection unit. The temperature inside that unit climbs to between 160 and 200 degrees Celsius, hot enough to melt the EVA into a semi-liquid state. Too hot and the material decomposes. Too cool and it won't flow properly. The temperature control has to be absolutely perfect. Once the EVA reaches the right consistency, it gets injected into a metal mold at pressures ranging from 600 to 800 kilograms per square centimeter. For perspective, that's roughly equivalent to the weight of a small car pressing down on every square centimeter of the mold. At some facilities, like the ones producing premium performance shoes, the pressure can reach as high as 1,200 bar. This extreme pressure forces the molten EVA into every tiny detail of the mold cavity, ensuring consistent density and perfect replication of the sole design. And here's where the science gets really cool. Mixed into those EVA pellets are two secret ingredients: a blowing agent and a cross-linking agent. When the molten EVA hits the heated mold, which is maintained at around 170 degrees Celsius, the blowing agent decomposes and releases gas bubbles. Think of it like baking a cake. The heat activates the leavening agent, creating air pockets throughout the material. But unlike a cake, we can't just let these bubbles expand randomly. The mold is designed to open rapidly at precisely the right moment, allowing the trapped gas bubbles to expand in a controlled way. As the sole ejects from the mold and hits the air, it literally puffs up, sometimes doubling in size. Meanwhile, that cross-linking agent is forming chemical bonds that stabilize the foam structure, locking those air bubbles in place and giving the sole its characteristic bounce and cushioning. The entire injection molding cycle takes about 20 minutes per piece. For popular sizes, factories will run multiple molds simultaneously. Otherwise, production would be painfully slow. The result? That bouncy white foam sole that cushions every step you take. Some manufacturers have taken this even further. Adidas developed Boost technology, which uses thermoplastic polyurethane pellets instead of EVA for even more energy return. New Balance has experimented with 3D printed resin soles called triple cell, but EVA injection molding remains the workhorse of the industry, combining performance, cost-effectiveness, and scalability. The glue, when robots apply adhesive better than humans ever could. Now comes one of the trickiest parts of shoe manufacturing, getting that upper and sole to stay together permanently. For decades, this was done entirely by hand. A worker would grab a bottle of adhesive and squeeze it around the perimeter of the sole, trying to apply an even bead of glue without smearing it everywhere. The results? Inconsistent at best, glue would end up in the wrong places. Too much in some spots, not enough in others. Enter the robots. Modern sneaker factories now use vision-guided robotic arms for glue application, and the precision is absolutely incredible. Here's how it works. As each sole arrives at the gluing station on a conveyor belt, a 3D vision camera scans it while it's still moving. The camera captures a point cloud, essentially a three-dimensional map of the sole's exact shape and position. This is crucial because not every sole is perfectly identical and they're not always oriented the same way on the belt. The vision system's algorithm processes that point cloud data in milliseconds, identifying the exact edges of the sole and calculating the optimal trajectory for glue application. It compensates for any irregularities in the sole shape or positioning. This trajectory gets converted into robot coordinates and transmitted to the robotic arms controller. No manual programming required. No skilled robot operator needed on the factory floor. After the robot applies glue to the sole, another robot, or sometimes the same one, does the identical process for the upper. Two precise glue paths, perfectly aligned, ready to bond. The oven, baking shoes to seal the deal. You might think the next step is just pressing the upper and sole together. Not so fast. That glue needs to be activated first, and that's where the heat comes in. The glued components travel down the assembly line on a conveyor belt into what looks like a giant industrial oven. This isn't about cooking the shoe. It's about activating the thermoplastic adhesive. These heat-activated adhesives remain dormant at room temperature, but when exposed to specific temperatures, they become incredibly tacky and form molecular bonds that are nearly impossible to break. The assembly line, orchestrating chaos into 200 pairs per hour. Now let's zoom out and see how all these processes come together. A modern sneaker assembly line is a carefully choreographed ballet of humans, machines, and conveyor belts. At New Balance's Lawrence, Massachusetts factory, every worker on the line spends an average of just 22.5 seconds on each shoe before passing it to the next station. That's not a typo, 22.5 seconds per worker per shoe. The 3 production lines running identical products in different sizes and colors, all moving in perfect synchronization. From the moment raw leather gets cut on the CNC cutting machine to the final lacing and quality inspection, each pair passes through a 55-step process involving 220 workers on a single shift. The conveyor belt is the unsung hero of this operation. Using stepless variable speed motors, the belt can be adjusted to match the pace of production, sometimes crawling along at a deliberate speed for complex stitching operations, other times zipping components from station to station. The belts are made from materials that can withstand high temperatures as they pass through drying ovens and heating chambers. In the fully automated speed factory concept that Adidas pioneered in Germany and Atlanta, the workforce was even smaller. Just 160 employees producing 500,000 pairs annually. That's over 3,000 pairs per worker per year. The robots handled the heavy lifting, laser cutting, precision gluing, heat bonding. Humans focused on quality control, machine operation, and the few tasks that still require human dexterity like lacing and final inspection. Here's what's mind-blowing. In traditional Asian factories, it can take 60 days to manufacture a shoe from start to finish, then another 60 days to ship it to Western markets. In a speed factory, the same process takes as little as a few hours. Every step is a minor miracle of modern manufacturing. 200 pairs an hour. That's what happens when human ingenuity meets cutting-edge technology on the factory floor. And honestly, that's just the beginning.